Can Time Run Backward? Chapter 1. The Arrow and the Mirror. You and I live at the tip of an arrow we cannot see. Every morning we wake to a world in which coffee cools in a mug, leaves crisp and crumble in autumn air, and 1,000 small decisions drift behind us like a thread unwound. We rarely pause to ask why the arrow points the way it does, or whether it must point at all. We accept without protest that eggs go from intact to scrambled, never the reverse, that ash scatters from a fire rather than reassembling into logs, that our memories stack neatly in a single direction yesterday before today, today before tomorrow, like pages. You can only turn forward, and yet the equations that claim to govern the bones of the universe, the deep grammar of quarks and photons, are ambidextrous. They do not flinch if you run them backward. They sing just as sweetly when you flip the score. Can time run backward? The question sounds like a magician's gimmick, a trick with mirrors and smoke. But to take it seriously is to walk onto the quiet stage where physics rehearses the meaning of reality. If we listen there, if we sit in the front row and let our eyes adjust to the dim light, we will see that our arrow is stranger than it appears, and the mirror, when angled just right, reflects more than our faces. It reflects the rules. Let us begin with a cup of tea. You drop a sugar cube into hot water and watch the crystalline white vanish into amber. The sweetness spreads, then smooths out. You know what comes next. It will never spontaneously recollect into a perfect cube and leap back into your spoon. That small certainty sits at the heart of our ordinary world. But the molecules of sugar obey laws that do not mind direction. If you filmed their dance in reverse, those laws would nod by all means. Your eyes, though, would revolt. They would call it impossible. Why? Because of entropy. The quiet accountant of fate. Entropy, a word that sounds like slow rain, measures how many ways a system can arrange itself while still looking the same to us. A deck of cards, freshly ordered, has low entropy because very few arrangements scream perfect sequence. Shuffle it once and you multiply possibilities. Shuffle it 1,000 times and you drown in them. The universe appears to prefer states with more ways to be. It is not a preference born of will, but of counting. There are simply more messy rooms than immaculate ones, more ways for your sugar to disperse than to reconvene, more configurations of air that look like a soft breeze than a hurricane assembling itself from stillness. The second law of thermodynamics, the sovereign sentence, merely says that in a closed world entropy tends to increase. Tends, not must. A coin tossed 1,000,000 times tends toward half heads. A sequence of 1,000,000 heads is not forbidden, only fantastically unlikely. We navigate a cosmos where the number of messy arrangements outweighs the tidy ones so dramatically that we rarely, if ever, see the exceptions. And this is the arrow. Not a spear flung by gods, but a statistic. Time, as we feel it, is the direction in which entropy grows. But entropy is not the only clock quietly ticking in our lives. In the physics of small things, the electrons humming near your fingertip, the quarks drumming in a proton, the equations are, with some subtle caveats we will visit, symmetric. They do not distinguish past from future. Swap T with MT, and the machinery continues. It is like reading a musical score backward and discovering the harmonies still fit. So why do you and I feel a preference? The answer, like a stubborn knot, hides in the boundary conditions, the universe's opening move. Imagine you enter a movie theater a few minutes late. The story on screen is chaos, a battle, a lover's quarrel, a car skidding on winter ice. You cannot tell how the characters arrived here, but you sense an order running beneath the disorder because the beginning, which you missed, has seeded it. Cosmology says our universe began in a state unbelievably smooth, clean as a polished mirror. You would expect a colossal blaze like the Big Bang to be disorderly, the way you expect a shattered glass to be more jumbled than a whole one. But the early cosmos, in the way gravity measures order, was an exquisitely low entropy state. In that smoothness lay the conditions for the arrow we ride. There were more ways to go toward clumpiness, galaxies, stars, paying you, than to remain perfectly uniform. So, like the sugar cube, the cosmos fled toward the numerous. We are the beneficiaries of that flight. Now for the mirror. Suppose I film you dropping the sugar cube and then run the tape backward. The cube jumps from the T, water cools a little, steam condenses neatly into the air, and your hand rises with a perfect white square pinched between fingers. Is this scene merely rare or physically impossible? Could the universe, once in a while, like lightning finding some shy branch, run this reversal within its own laws? Here is the strict answer. It is allowed. Nothing in the microphysical rules prohibits it, but the odds are so desperately small that you would wait longer than the lifespan of stars to witness it. The height of improbability here is blinding. Every molecule of water and sugar must conspire, correlated with diabolical precision, to retrace a path through an abstract space of arrangement so vast it humbles the mind. To ask if time can run backward, in this sense, is a little like asking if all the molecules in your room might gather in the corner and suffocate you. Yes, in principle. No, not in any life you or your grandchildren will live. And yet, there is another kind of backwardness, one the equations flaunt with impish courage. If you could take a snapshot of the world at some moment, positions and velocities for all particles, and then change the sign of all velocities, sending every motion in reverse, the world would, in the absence of memory's meddling and heat's leakage, retrace its steps. Loschmidt, a 19th century critic of Boltzmann's kinetic theory of gases, nurtured this objection like a thorn. If the laws are reversible, how does entropy grow? Boltzmann's reply, delivered half in equations, half in intuition, relied on probability. Almost all initial states evolve into higher entropy states for almost all times, because higher entropy states are overwhelmingly more numerous. But Loschmidt's mirror still sits on our table. If you prepared the world in one of those contrived, velocity-reversed states, it would anti-scramble melt back into order. But who prepared the world? Who tilted the mirror? This is where the past hypothesis stands like a quiet commandment. The universe began in a special, low-entropy condition, and that specialness cascades forward. It is what lets memory function. One always records a lower entropy past into a higher entropy present. It is what lets causes precede effects in the narratives our brains prefer. Neurons fire, muscles move, a footstep leaves a print, not the reverse. We become creatures of the gradient. We surf the slope of likelihood. Does any of this answer the question in your chest? Not yet. Your chest asks, could I step into a machine and feel time reverse around me? Could I watch the coffee warm, see ash gather itself, unsay a word and hear it climb back into my throat unsaid? Could I become younger? Not just younger looking, but actually younger, the cells in my body shedding error, the telomeres on my chromosomes unfurling like reed-knitted scarves? Or is the backward-running universe forever a ghost, a mirage shimmering in equations but never coalescing in experience? To take that question seriously, we must visit two further axes of the problem: symmetry and choice. First, symmetry. Physics contains a trinity of transformations known by their initials: C for charge-swap particles with antiparticles, P for parity, flip left and right as though in a mirror, and T for time reversal, run the film backward. Astonishingly, the combined operation CPT is a sacred symmetry. Any process permitted by our best theories looks identical if you flip charges, mirror space, and reverse time all at once. This is not merely a poet's notion, it is cemented into the structure of quantum field theories that match experiment with 10 decimal places of precision. It whispers, in its deepest bones, reality does not privilege forward over backward, merely this together over that together. But, and here is a wrinkle we must not smooth over, nature does violate T-symmetry on its own in a subtle arena of particle decays. Certain mesons, fleeting composites of quark and antiquark, misbehave. They treat forward and backward differently at a level discernible in colossal experiments with detectors as large as cathedrals. The violation is unimaginably tiny compared to the tsunami of entropy, and it does not grant you a time machine. But it matters because it shows that, even in the skeleton of the laws, there are knotted spots where direction leaks in. The arrow in the lab remains the tyrant of the arrow in the kitchen. T-violation is a candle. Entropy is the sundae. Second, choice. You might decide to cheat the odds. What if you build devices that massage the improbable into the actual Maxwell's demon? A tiny imp that opens and shuts a door between two gas chambers, letting fast molecules collect on one side and slow ones on the other, decreasing entropy by cleverness? The demon, if it could keep perfect records without cost, might reverse your sugar cube's fate. But the demon pays to measure, to remember, to erase the past so it can act again. These acts burn order. They crunch possibilities. They spill entropy into the world like heat from a slipped belt. Landauer's principle, a jewel of information theory, declares that erasing one bit of information dumps a minimum of heat into the surroundings. Your demon wins locally, loses globally. The devil, accursed, cannot bankrupt the second law. Where does that leave our question? On the one hand, time's direction emerges from mathematics that do not insist upon it, shaped by a peculiar beginning and fanned by statistics into the wind we call later. On the other hand, in tiny corners of physics, time is not entirely neutral. The laws carry small asymmetries that break the delicate tie. And you, human, warm, conscious, are a machine stitched to the arrow at every seam. Your neurons require gradients, your memories require asymmetry, your very metabolism is a harness around entropy's mighty horse. To ask time to run backward around you is to ask your life to become alien to itself, but we can still peer into more exotic mirrors. General relativity, Einstein's cathedral in the landscape of mind, permits geometries of space-time so twisted that a traveler might return to her own earlier self. These closed time-like curves spiral like slinkies around cosmic strings or inside the throats of certain solutions where mass energy warps a path so steep you could descend and find yourself above where you began. Here, backward holds a different taste, Not molecules reintegrating on command, but world lines looping through the weave. Could she go there, the traveler? Could she tap a shoulder that belonged once to her? The mathematics says, with taste and care, yes, with raw engineering and rawer luck. The universe says, not so fast. Quantum fields snarl at such loops. Paradoxes breed like rabbits. Protective conjectures rise like hedges to keep you out. Yet even here, what is backward depends on a choice of coordinates, a way of slicing space-time into nows. We meet a deeper lesson. Time is not one thing, universal and inescapable. It is local and relational, braided with motion and gravity. It passes differently on the mountain and the plain, in the spaceship hurtling and the cradle asleep. If backward has any meaning in such a world, it will be the meaning of a story, not a river with a single channel. And so we come to a second scene less theatrical than tea and sugar, more patient and vast. The cosmic microwave background, the oldest light we can see, bathes us still. It is almost uniform, but not quite. Tiny ripples, seeds of galaxies, salt the sky. In its hush, we hear the beginning's gift, low entropy in gravitational degrees of freedom. The arrow we ride was minted there. If time could run backward, the microwave glow would grow smoother, not rougher. Galaxies would unspool into mist. Stars would unwind their fusion into pristine hydrogen fog. The world would not become a movie played in reverse so much as a fog returning to an earlier clarity. Your coffee cup would be irrelevant. Your memories, those private fevers, would not survive the grand reversal. You would not be you. There is one more mirror I must place on the table, and this one is personal. Memory feels like proof. We remember the past, not the future. Therefore, the past is real and the future airy. But memory is a physical process, as much a transaction of entropy as a firefly's glow. To write a memory into tissue is to rearrange molecules in a way that dissipates energy in the form of heat and increases overall entropy. That is why the future does not leave traces in us, not because the future is unreal, but because the recording process itself is directional. We cannot build futural memories without violating what memory is. So, we misread the arrow as an absolute. We feel the one-wayness as fate. This is where the poetry of the question lives. Can time run backward? Depends first on what we mean by time, second on who is doing the running, and third on what we accept as backward. On the scale of molecules, the answer is sometimes, in principle, under contrived conditions. For brief spells, at astronomical improbability, yes. On the scale of you and me, in kitchens and cities, with lungs, laptops, and laughter, no, in practice, it cannot, because to become such a world, we would have to annihilate the very conditions under which our world produces us. On the scale of space-time quilts, this question branches into others. Could geodesics loop? Could causality become a maze? And the answers are hedged by conjectures and cautions. But I promised you a book, not a verdict, a path, not a signpost. And a path has stones. Let us pick some up. Stone 1. The microphysical law's reversibility. Newton's equations, Schrödinger's equation, Maxwell's equations. These are time reversal invariant in their pristine, idealized forms. If you were a god who could reach into a system and flip the velocities of all particles, you would create a world that runs back to where it began. The odds of randomly finding such a precise microstate are vanishing, but gods do not rely on odds. Humans, however, build computers, not miracles. Still, we can try small-scale echoes, spin echoes in nuclear magnetic resonance experiments, where spins dephase, a kind of entropy growth, and ingenious pulse sequences rephase them, an experimental whisper that certain kinds of apparent disorder can be unwound if you maintain exquisite control. This is not time running backward. It is a violinist playing a phrase and then playing the retrograde. The air between is not returned to its prior stillness, only the pattern is. Stone 2, the past hypothesis and cosmology's asymmetry. A rough analogy helps. Imagine a deck of cards. You prepare it in perfect order, low entropy, and then shuffle. The shuffling laws are symmetric. They do not prefer to increase disorder, but relative to the task of counting arrangements, almost every sequence is disordered. If you pick a random beginning, your arrow will point both ways. You would see increases toward the middle and decreases both into the past and into the future. A world with two arrows mirrored around a central now. But we do not live there. We wake up inside a deck that started ordered. Our arrow points outward. That starting point is the strange fact, the thing the universe chooses. We do not so far know why it chose so. We have guesses, cosmic inflation, multiverses, measures on spaces of solutions, but no signed confession. Stone 3, information as physics. The demon cannot beat the house. When we frame entropy in information terms, we begin to see the arrow running through logic and language, not only through boilers and stars. Computation itself has a thermodynamic cost if it includes erasure. The asymmetry of knowledge, remembering the past but not the future, becomes a consequence rather than a cause of the arrow. It gives us a principle for a different kind of backwardness. You can run an algorithm in reverse only if you retain all the information. Any loss produces heat, produces direction. Reversible computing exists in theory and in limited practice. Gates that conserve information, computations that can be run backward. They offer a metaphor for what the world might be without the arrow. But to make them practical at scale is to wander into engineering deserts where heat and error stalk every attempt. Stone 4. T-violation in particle physics. It is tempting to imagine antimatter as ordinary matter running backward in time. This metaphor grew from Feynman's diagrams, where an antiparticle can be drawn as a particle traveling backward in time. But that is the syntax of mathematics, not the semantics of experience. It is a convenient way to calculate, not a ticket to a reversed life. We do, however, measure tiny asymmetries in weak interactions. Kaons and B mesons decay in ways that reveal a preference. These slivers of T-violation leaf-thin cannot overturn the empire of entropy, but they remind us that the universe's symmetries are not perfect murals. They are frescoes with hairline cracks. Stone 5. Gravity's special status. Entropy for matter and radiation we count with tools forged in the 19th century. Entropy for gravity is a younger beast. Black holes, those dark geometries, carry entropy proportional to their horizon area. The story we have written about the universe's arrow passes through them. The early universe, smooth, low gravitational entropy. As structure grows, as black holes form and gluttonously eat, gravitational entropy increases. If we fantasize about a backward-running cosmos, we must fantasize about black holes that unform, horizons that shrink, hawking radiation that reassembles into coherent starlight, galaxies that drift apart into an exact uniformity without a single jitter. We must imagine gravity itself playing the violin backward. The mind staggers, not only because of improbability, but because the script combines quantum and space-time in a way we do not yet fully understand. Stone 6. You. The arrow is not only written in the sky, it is stitched into the way your brain turns perception into narrative. A memory is a map you keep of a landscape you no longer inhabit. The act of mapping consumes free energy and produces entropy. Consciousness, whatever else it is, seems to require a stream, the passage of states over others, a forward pulse. If time could run backward in the kitchen, could it run backward inside the brain? Would you then remember the future? The very structure of prediction and recall would invert. But the circuits that perform recall are wired by the very processes that rely on forward flow. To live in reverse is not merely to traverse events backward. It is to be a creature sculpted to the inverse gradient. Our biology is not built for that. Now, a confession. Every sentence so far has smuggled in a particular stance that time is a parameter, a coordinate layered over changes, a bookkeeping variable for dynamics. Some philosophers and physicists dissent. In the block universe picture, past, present, and future exist equally. Like a novel completed on paper, even if you read it page by page. There, the arrow is not in time itself, but in how patterns unfold along slices. In a different picture, time is emergent, arising from entanglement and the way subsystems become, for practical purposes, independent. In yet another, the present flows, a metaphysical addition to physics that grounds our sense of becoming. Each view shelters time in a different building. In all of them, the question, can time run backward, morphs. If time is a block, backward means reading from the last chapter to the first. If time emerges, backward means rebuilding the conditions that give rise to the direction of emergence. If time flows, backward would be a change in the flow itself, like a river reversing under the pull of a supermoon. And so, finally, let us gather the thread and tie a knot you can carry in your pocket. Can time run backward? If you mean, can the equations permit a mirror world where every motion and interaction is replayed in reverse, the answer is yes, in principle. If you mean, can nature, by accident, assemble such a microstate so that your kitchen unbrews its tea and your ash unburns, the answer is no. For all practical lives, the odds are astronomically small. The universe's dice loaded by sheer counting. If you mean, can space-time bend so that your path loops into your earlier self, the mathematics sometimes suggests a loophole, but the full physics, quantum fields, energy conditions, cosmic censorships seems to board up the exits. If you mean, can you build devices that reverse local disorder? The answer is yes at small scales with care, but the bookkeeping oath of entropy will collect its tax elsewhere. If you mean, can you, as a person, feel time reverse memories, unwinding, choices unmade, the answer is bound up with what a person is. To be you is to be a story told on an arrow. Reverse the arrow, and you change the story so severely that the protagonist evaporates. But a book cannot end in the middle of chapter 1 on a pile of stones and disclaimers. We need an image to carry, something more than rules. Imagine a long corridor with polished floors. Along one wall are mirrors, and along the other are windows. Through the windows you see the world you know, bustling streets, drifting clouds, phones buzzing, children chasing a dog. In the mirrors, you see the same, but backward. A symphony's coda becomes its prelude. A glass unbreaks into a hand. A sunset blooms into noon. You walk. In your pocket sits the knot. Entropy's arithmetic, the beginning's odd smoothness, the small cheats of demons and echoing spins, the blocked alleyways of closed time-like curves. The mirrors are not lies. They are alternate grammars of the same story. But to enter them, to live there, you must rewire the windows, and in doing so, you unmake the walker. At the end of the corridor stands a door. Above it, a sign, boundary conditions. Beyond, the beginning of the universe hums, low entropy and luminous. If we could learn why the sign reads as it does, if we could replace the past hypothesis with the past explanation, we would draw nearer to the heart of the arrow. Perhaps we would learn something about backwardness not even the mirrors can teach. For now, we continue down the corridor, windows to our left, mirrors to our right, arrow in our bones. We drink our tea, knowing it will cool. We make promises, write them down, remember them tomorrow. We light fires and fall in love, and let the ash go where it will. We exist on a slope, and the slope gives us seasons, music, speech, but the question remains, whispering like a draft through the hinges. If the laws themselves are ambidextrous, who made the door swing this way and not the other? In the next chapter, we will stop simply staring at mirrors and windows. We will sketch, with as much honesty and precision as humans can claim, the machines and maps that would be necessary for an actual reversal. The thermodynamic accounting, the role of quantum measurement, the edge cases where time's fabric seems to twist, and the ethical dissonance that would arise if choice itself could be walked backward. We will do this not because we expect to build a time reverser that dream belongs to fairy tales, but because, by testing the limits of the arrow, we learn what carries us forward. For now, let me end with a smaller, kinder thought. The arrow that points from yesterday to tomorrow is not only a sentence, it is also a gift. It allows warmth to flow and seeds to sprout and music to resolve. It allows regret to teach and grief to loosen and forgiveness to become real. Backwardness may be a mirror we can calculate in, but forwardness is the canvas we can live on. And you, reader-listener, are an artist of that canvas. Chapter 2. Machines, Mirrors, and the Edge of the Map. You asked for a door that opens, not merely a pane of glass to press your forehead against. If Chapter 1 wandered the corridor of mirrors to ask whether the image of backward time is a physical possibility or a trick of perspective, Chapter 2 is a walk with a toolbox. It is not a heist. We won't sneak past the second law of thermodynamics and pocket its crown, but we will inventory everything we can actually build, measure, and imagine, right up to the point where imagination becomes a scaffolding around our ignorance. In the end, the question, can time run backward, will be pinned to a simple table: what the laws allow, what initial conditions afford, what devices can do, and what living creatures require. Take a breath. Let's open the box. The dials we can turn. Reversals in miniature, echoes, unitaries, and contrivances. If you whisper into a canyon, you sometimes hear yourself returning a moment later, voice bent by landscape. Physicists make canyons in Hilbert space an abstract space where quantum states live, and they whisper with pulses, then listen. In nuclear magnetic resonance, A sample's nuclear spins begin aligned, then dephase. Each spin precesses at a slightly different rate, and their vector sum fades. A clever sequence of radio frequency pulses can flip the spins so that the dephasing rewinds, the spins rephase, and an echo bursts into the detector. Disorder seems to unhappen, but study the bookkeeping. Nothing violates the second law. The system is tiny, control is exquisite, and the reversal depends on keeping track of the very correlations that would be unmanageably vast in a mug of tea or a living brain. It's like asking a library to return to its pristine order by remembering, for every single book, the precise path it took through every hand and shelf since opening day, then compelling all librarians and patrons to retrace those steps in reverse. You can do it for 3 books on a quiet afternoon. You cannot do it for the Library of Congress during a festival. Similar tricks exist for classical waves. Scramble a wavefront through a turbid medium milk fog, a frosted window, and with a phase conjugate mirror that inverts the wave's phases, you can force it to retrace its path and refocus. Again, control, correlations, boundary conditions. The backward flows only because you clamp down on variables that in a macroscopic world sprawl into the millions of trillions. In quantum mechanics, the fundamental evolution, when a system is isolated and unmeasured, is unitary and reversible. You can, in principle, uncompute what you computed step by step, so long as you never let information spill into an environment you cannot retrieve it from. That ideal is why quantum error correction is a cathedral of ingenuity. It corrals information that would otherwise leak into heat and noise. But isolation is a fairy tale for big things. The larger the system, the harder it becomes to prevent entanglement with air, light, lattice vibrations, or the thermal jiggle of the apparatus that tries to hold still. Decoherence, that quiet assassin, doesn't destroy information. It smears it across degrees of freedom you don't and can't track. Reversal mutates from a linear algebra exercise into a demand that you heard the weather. Outcome: we can make tiny tapes play backward for controlled scenes, the everyday arrow, your breath fogging a mirror, your phone warming your palm does not yield because you have no hand big enough to hold all its correlations. Maxwell's demon and the cost of cleverness. A century and a half ago, James Clerk Maxwell imagined a neat-fingered being guarding a door between 2 gas chambers. By opening the door only for fast molecules moving one way and slow molecules the other, the demon could sort hot from cold, lowering entropy and seemingly forcing time to shuffle its feet. Later thinkers sharpened the puzzle until a clear edge cut through it. The demon's knowledge is physical. To measure and store the bits that tell it when to act is to write to a memory. To make room for the future, the demon must erase the past in its register. Rolf Landauer put the price on erasure. Each bit wiped dumps a minimum of heat into the environment. The entropy ledger balances. The demon's gain is paid for at the cashier by the act of tidying the demon's own mind. Engineers have built demons. In the lab, feedback-controlled devices can rectify thermal noise and extract work as though they had coaxed motion out of randomness. Every triumph carries a receipt. Measure, decide, act, reset the loop costs, and the cost goes as heat. There is no free unscrambling. There is only moving scramble elsewhere. If your dream is to walk through your kitchen and watch coffee jump into a kettle, then climb back into the kettle warmer than you left it, a demon would have to monitor astronomical numbers of molecules and coordinate an equally astronomical number of door openings. The demon's journal would be larger than the kitchen. Its memory would be hotter than the stove. Outcome: intelligence can locally reverse disorder by spending ordered fuel information itself. The arrow bends in a small neighborhood, but it snaps straight in the larger world. Reversible computing and the fantasy of zero heat. What about building machines whose logic is perfectly invertible? A reversible gate, like the Toffoli gate, maps inputs to outputs in a one-to-one way, allowing you to run the computation backward from output to input. Theory proves if you never erase, if you keep every scratch bit, if you cling to every meta-scratch bit, you can compute without dumping heat purely because of information loss. But never erase is like never exhale. The cost moves from logic to materials. Friction, resistance, leakage currents, stray photons. The demons of hardware don't care about your logical neatness. Practical, reversible computing promises efficiency gains, not miracles. Run backward all you like. The room still warms. Outcome: at the level of logic, backward is possible. At the level of life, every useful computation includes forgetting. Forgetting is heat. Heat is arrow. The places geometry might help. Closed, time-like curves, loops that not causality. General relativity is geometry with teeth. It says mass energy tells space-time how to curve, and space-time tells mass energy how to move. Among its strangest solutions are closed time-like curves, CTCs, where a path through space-time loops back and a traveler could meet an earlier self. Gödel found one in a universe that rotates as a whole. Kip Thorne and colleagues discovered that certain wormhole constructions, when accelerated or placed in gravitational potentials, could become time machines. These are not holes you dig. They are throat-like shortcuts in the fabric, where near and far are topological opinions rather than distances you can measure with a ruler. We quickly run into the thorns. CTCs invite paradoxes. The grandfather who is never born, the letter that writes itself, the billiard ball that knocks its past self off course in precisely the way that ensures the collision. Two responses emerge. The first is Novikov's self-consistency principle. In any world with CTCs, only globally consistent histories occur. You can meet your earlier self, but you can only do things that, in doing them, ensure that you did them. This turns free will into a choreography that knows its own music. Time does not run backward. It runs in a loop where cause and effect are braided tautly. The second is David Deutsch's quantum approach, in which systems on CTCs settle into fixed points of a consistency map. You can compute probabilities for outcomes, but the price is strangeness. Nonlinearity in state evolution, the possibility of perfect state discrimination, and other powers that would rip open cryptography and computation as we know them. Quantum field theory, the enormously successful framework that marries special relativity to quantum mechanics, glares at these time loops and hums disapproval. Hawking proposed chronology protection. The universe conspires through quantum effects that explode stress energy near would-be CTCs to prevent time travel on macroscopic scales. Even if a wormhole could be stabilized, it demands exotic matter with negative energy density to hold the throat open. Negative energy exists in carefully prepared quantum states, The Casimir effect between plates is the poster child, but nature rations it. Quantum inequalities fence off how long and how strong negative energy can be. You can't heap enough strangeness to build a tourist's time tunnel without breaking the fence. Outcome: geometry permits loops in thought experiments. Full physics, quantum fields, energy conditions slams doors. Even if a loophole exists in the far corner of theory space, it would not reverse your T. It would tangle causality, not entropy. Gravitational arrows and black holes. Gravity grants entropy a second story. In the early universe, matter was smooth, low gravitational entropy. As it clumps, gravitational entropy rises. When black holes form, it spikes. A black hole's entropy is proportional to the area of its event horizon, a staggering count of microstates that we do not yet see directly, but which holographic theories and string calculations hint are the ways space-time itself can rearrange. Now, imagine time running backward on cosmic scales. Galaxies would dissolve into haze, black holes would unform, Hawking radiation would reassemble into coherent matter, and the ripples in the cosmic microwave background would smooth back to uniformity. This is not a film run in reverse so much as a universe unlearning complexity in a way that requires every particle of light to carry a conspiracy. The initial condition to make that happen is not only special, it is so special that comparison falters. You would be arranging the positions and momenta of every quantum of the universe with supernatural precision, so that not only matter, but space-time curvature itself unweaves. Outcome: in gravity's house, backward means unmaking structure. Possible by equations, absent by initial conditions, pulverized by probability. The wiggle in the laws themselves, T violation, and the small crack in the mirror. The deep laws largely treat past and future symmetrically, but the weak nuclear force cheats. In decays of kaons and B-mesons, minuscule asymmetries tell us that if you reverse time but change nothing else, the statistics of outcomes change. Combine this with charge conjugation and parity flips C and P, and you recover the sacred CPT symmetry. T violation matters for the cosmic asymmetry between matter and antimatter, but its scale is tiny compared to the tyrant entropy. It doesn't give you a lever to pull in the kitchen, the lab, or the heart. Outcome: time is not perfectly neutral in microphysics, but the crack is a hairline. It is not a door. Measurement, collapse, and the arrow inside observation. Quantum theory is a duet. Smooth, unitary evolution and sharp, probabilistic measurement. Whether you regard collapse as real or as an update of knowledge in a larger unitary evolution that includes the apparatus, there is an asymmetry in use. We prepare pure states and measure mixed outcomes. We predict statistics forward, not certainties backward. Entanglement grows easily. Disentanglement is contrived. In many worlds' pictures, the branching that carves a definite classical world out of quantum potential is tied to decoherence. Another entropy story. In objective collapse models, the collapse has a time direction built in. Either way, observation in practice nails its colors to the forward mast. Outcome: how we come to know the world depends on processes that ally with the arrow. Our knowledge unfolds forward because the making and unmaking of records is thermodynamic, not because the future is unreal. IV. Time in the body and the mind. Biological time, metabolism, and memory. Life is an island of local order, maintained by throwing entropy into the sea. Metabolism is a controlled burn. Photosynthesis and respiration are the shuttles of order. Aging is not a simple meter, but the accumulation of molecular damage, epigenetic drift, protein misfolding, and stochastic insults, all paid for and partly corrected by energy. To run backward, biologically, is not to flip a universal time dial, but to reverse or outpace these processes. Repair DNA, refold proteins, reset methylation patterns, recycle damaged organelles. Medicine is learning to tug some of these levers. Rejuvenation is feasible in pieces. Time reversal is not. Memory completes the tale. To remember is to write to strengthen synapses, alter gene expression, change dendritic spines. Writing consumes ATP, forgetting remodels circuits. Both increase environmental entropy. Could you, in principle, reverse every molecular change of a memory's creation? Only if you also reverse the flow of heat into the glia, the blood, the skull, the room. Only if you walk the entire universe backward along the thread of that thought. Short of that, you can erase memories, not rewind them. Psychological time, the feeling of flow. Humans do not sense time as a number. We sense it as a rhythm, elastic and subjective. Fear lengthens moments, delight shrinks them, boredom dilates the school day, awe gives an hour a cathedral's worth of spaces. Neuroscience suggests that our perception of duration arises from population codes, ensembles of neurons whose firing patterns encode intervals from milliseconds in the cerebellum to seconds in basal ganglia loops to extended spans in prefrontal and parietal cortices. These codes are directional because they are computational. They integrate over spikes, update priors, collapse uncertainties. They are not clocks you can crank backward to feel yesterday. If a surgeon could run a local circuit backward in time, the rest of your brain would not co-sign the illusion. It would experience a seizure, not a rewound afternoon. Outcome. The lived arrow is inside us. Even if the cosmos offered a trick, we would not be the same creatures on the other side of it. V. Ethics of a reverse. Suppose the universe winked and blessed you with a lever that could reverse the last minute in a cubic meter of space with perfect microphysical fidelity. You could unsay a word, unspill a cup, unpress a trigger. What then? Who owns that minute? Outside your cubic meter, sound waves already departed, photons already left. Those must be wound back too, or your minute will return to the present like a counterfeit. Edges mismatched, marks off register. Extend the bubble, and you soon encompass persons who did not consent to being remade, choices they made in forward time, reauthored by your hand. Extend further, and causality buckles. You must repair not only the energy and matter, but also the statistical ensemble. The probability distributions of moods, of micro-states in blood and brain that existed 60 seconds ago. You would be author, historian, and censor. We tell stories about time reversal because we hunger for repair. We want to take back the phrase that hurt a friend, the left turn that led to the accident, the diagnosis that arrived a month too late. The fantasy is a moral instrument, but in the physics we inhabit, repair means forward acts, apology, compensation, discovery, treatment. The past cannot be undone, only recontextualized by the future we make. The arrow is how responsibility has teeth. Why? What a yes would have to mean. We can now reframe the question with more precision. Version A. Microscopic reversibility. Can time run backward? Yes, in small isolated systems where we control and track correlations, we can engineer dynamics that reverse the growth of certain kinds of apparent disorder. Echoes in NMR, phase conjugation in optics, time reversal mirrors for acoustic waves, each is a narrow yes. They are not refutations of the arrow. They are confirmations that the arrow is not a brute rule of the equations, but a consequence of typicality in enormous spaces of possibilities. They are science's way of playing palindromes on the violin. Version B. Macroscopic improbabilities. Can time run backward? In principle, the microphysical equations allow a cup to unmix, ash to reassemble, a scrambled egg to reovate. In practice, no. The probabilities are absurd. The initial conditions required are beyond even thought experiment plausibility in an open universe. If you saw such a thing, you should suspect that someone prepared the trick that a demon wasted galaxies of free energy to stage a few seconds of wonder. Version C. Geometric shortcuts. Can time run backward? In general relativity's wild garden, you find CTCs and wormholes that twist causality. Their status in full quantum gravity is likely forbidden, even granting some loophole. Backward. There is not the reanimation of cooled coffee, but a world line that meets its younger self, subject to global consistency constraints. The arrow of thermodynamics would still hold you by the collar. Version D. Personal backwardness. Can time run backward? For a person, memories unscribed, tissues unaged, the answer is no in any sense that preserves identity. Biology can repair and rejuvenate. It cannot reverse the film. If we ever approach such power, it will be through forward technologies that rebuild, not rewind. VI. Why the arrow exists at all. All roads in this book pass through one crossroads, the specialness of the past. We inhabit a universe that began in a low entropy state. Why? Inflationary cosmology smooths wrinkles and seeds structure, but does not, by itself, answer why low. Some approaches suggest that typicality, in a huge space of possibilities, picks out histories with two low entropy ends, giving two arrows pointing away from the middle. Others lean on multiverse measures or on the claim that asking for a reason is a category error. The boundary condition is a fact, not a theorem. Emerging ideas in quantum gravity hint that space-time and its arrow could be emergent from entanglement patterns in a deeper holographic description. If so, the past hypothesis might translate into a statement about simple boundary states in a more fundamental theory. For our purposes, the moral is crisp. The direction you live is not an illusion, not a human weakness, not a metaphysical add-on. It is the way overwhelming probability flows given where the cosmos started. The laws do not stamp forward only on the parchment, but the boundary line at the top of the page and the combinatorics of letters ensure that the story reads left to right. VI. What to do with a one-way street. A hard truth becomes a friend if you know what it's good for. What is the arrow good for? It gives meaning to cause. If balls roll down a slope, you can plan a mill. If entropy rises, you can build engines. The first steam engines were clumsy treaties with the arrow. Modern heat pumps are fluent negotiations. Information theory, how we compress data, secure messages, design error-correcting codes, was born from counting microstates. Every photograph you take is a bargain with entropy. The camera reduces uncertainty about a scene by increasing entropy elsewhere. To design computers that sip energy, we need to honor Landauer's bookkeeper. To cool quantum bits and keep them coherent, we embrace, not deny, the river's flow and build levees where turbulence would otherwise drown the signal. It gives meaning to memory. You are a time-bound creature. You cannot store the future. But you can write diaries and logs, take measurements, archive evidence, build institutions that preserve practices and knowledge. Science itself is a machine for carving order out of the flood by making records that survive scrutiny. That is not a lament, it is a superpower. The future is a blank you can mark. It gives meaning to promise. A promise is an arrow sent forward. If time could run backward on Tuesdays, contracts would be jokes. Responsibility rests on the fact that what we do persists, not because the universe is a moralist, but because the direction of entropy makes persistence into structure. Ethics is physics with a human face. Ix. The story ends where it began. If I could take you to the mouth of the universe and show you its first breath, the low entropy hush from which all this tumbling variety fell, you would not see a pointer saying, "This way forward." You would see smoothness, and in that smoothness, the promise of change. You would see a landscape with more ways to crumple than to remain pristine. You would see a corridor already building itself, not with mirrors and windows, but with probabilities. The arrow is not a tyrant. It is a likelihood wearing a crown that cannot be toppled by any finite conspiracy. So, can time run backward? In our equations, yes, if you prepare states with the delicacy of a god and accept that backwardness is a narrative device, with no room for the messy hero called life. In our machines, yes, if you restrict the stage, count every step, and spend order elsewhere to buy your reversal. In our cosmos, not in any way that will return milk to the jug or words to the mouth. In our hearts, not at all. We are written in forward ink. What should we do with that? Live like artists who know that paint dries. Let the drying be part of the beauty. Compose with the knowledge that the resolve must come after the tension. Apologize when you need to, precisely because you cannot rewind. Learn because memory is costly and precious. Build engines that sip rather than gulp, because heat is the language of loss. Guard your attention, because every deletion in your mind is a tiny burn. When you set down this book and step into your day, you'll find the arrow everywhere. In the cooling of a windshield, in the accumulation of dust on a shelf, in the way laughter dissipates into the air after dinner. None of it is tragic, not by necessity. The arrow is also how flowers open and clouds form, how bread rises and symphonies resolve, how a child's vocabulary expands, how an old friend's letter acquires stains in the corners, evidence of years handled. The forwardness of time is the world's invitation to make. If there is a miracle here, it is not in the fantasy of a rewind button. It is in the fact that a universe that began smooth found a way through the drift into complexity to make beings who can ask such a question and hear in its echo the shape of their own days. We will not run backward, but we can turn any time in the flow and look back with a kind of attention that honors what has happened without needing to undo it. Then, we can face forward again with the plain courage of those who know that the only way to fix the past is to build a better future. One act, one proof, one kindness, one discovery at a time. You and I live at the tip of an arrow we cannot see. Now that you've felt its weight and understood its craft, perhaps you can also feel its grace. The arrow is not against you, it is the current in which making becomes possible. It is the reason a blank page can turn into a chapter, and a chapter into a life.